Hi all, I want to say I'm so happy because I have an amazing video tutorial for the Onshape surface modeling. And in this video tutorial series, we're going to model Logitech mouse. We're going to learn some basic advanced features of Onshape surface modeling. Yeah, okay. This one is a very good tutorial for you to learn how to use advanced surfaces in Onshape. Therefore, let me now start a new, you can see this mouse, a new Part 2 Studio. And first thing we need is we need to understand how you're going to model this surface, this surface model of our mouse. As you can see from the front view, you can be able to see we have some curves here. I have this curve, you can see this curve. We have another one here at the middle. Let me go front view using this. You can see we have this and this here. That one is from the front view. If you go top view, you can see we have this curve like this and another one like this. Therefore, we are going to start by creating this curve here, this one here. Then we go next to this. Then from there, we are going to merge. Okay. Therefore, I need to start from the top view. Let me start from the top view. And I need a spline from this point like this, like that. Another spline here. I need two splines and match them at that point. Then I want to connect these two splines using a construction geometry and on to dimension from this point to this point. Okay, let me first for hide planes dimension from this point to this point. Oops. From this point to this point is 50 mm. Same case applies on this side is 50 mm, like that. Then these are the, let me know, this one to be vertical, this one to be vertical also, this to be horizontal and horizontal. This point can change this and this to be equal. Let's now dimension. Then from this point here, let me just insert a point for ease of selection. From this point to this point, I need 25.75 mm. Then from this point to this point along x-axis, I need 10.75. Okay, yeah. Then this one is a bit longer. This one is a longer. This one to be, let's see, 45. Let's see, 45. This one to be, let me first pull it. Okay. Let me see if this one, let's give one look. This one is 35 or 32. Let's go with the 33 there. This one to be, yeah, this is fine. Then this to be 18. Yes, fully defined. Okay, let me make this one 48. Oops, 46. Yeah, I think that's better. That's fine. Yeah. Then I need to extrude this curve to form surface like this to form surface. But let me go back to the top view and see some curvature visualization. Before I do that, let me see the curvature visualization here on this cover. This is okay. You have to do that at the sketch. Let's click here and let's see curve surface analysis. Yeah, you can see we have discontinuity here. You can see how from at this point you have discontinuity. Okay, meaning therefore, let me go back to this one here. This and this curve you have to be tangent. Yeah, the already tangent. You can see this is already tangent. That's fine. We have a G1 continuity at this point. That's fine. Yeah. Then we need to go now to the front view. The reason why we want to go to the front view is because we want to capture this curve. You can see this one here. Therefore, let's capture that on the front view. Sketch normal to you. Then I can hide this for now. I need a spline from this point, this point, this point, like that. Basically, I need two splines, not one. Okay, that's fine. This point to be this point, and this point to be at 10.75 horizontal. Oh, this one is a line. Oops, sorry for that. I need a spline. Yeah, horizontal also. Then I need this line here, like that, like that, like that. Horizontal. These are for the construction. Therefore, this one is not okay. I need to go a line here, like that. This one to be vertical. This one is for the construction, 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 and construction. Construction. We need to dimension this to be 50. Also, this to be 50. This to be 7. Okay, this to be 12. This height to be 25.75. Okay, then this one has to be horizontal. This one has to be short. This and this to equal. Also, this has to be short a little bit, maybe 20. Yeah, that's fine. This has to be around 18. This to be around 20. Yeah, that's fine. If you know I show my surface here on the front, I have to make sure this surface exceeds this. I can now change my extrude, maybe to use 80. Okay, because I want to split this face using this sketch, like that. You can see this side was not, we didn't split here because I'm using a face. I can also use part, then this part with this sketch. Okay, yeah, doesn't allow to use part. How to use face and your sketch. Basically, what's happening in the background is if I go back a little bit to explain something, when you say split, when you take this sketch and extrude the surface like that, where they intersect is where we are getting a line. Let me see whether you have that command for the intersection. You can see the intersection curve between this and this. If I hide this one here, we are getting this curve. Basically, it's like you are projecting the curve. Okay, that was by the way. Let's see. Yeah, I'm interested by the. I don't need this. I'm just interested by the top section here. Therefore, I can delete bottom. I can delete bottom like that because my main interest is this section here. I could have used projected curve also to achieve the same thing. You can see, let me go back, let me hide this surface. If I show this, could have also used projected curve. First sketch, I have to use this sketch here. Second, this sketch. See, I'm getting the same results. I'm taking this curve from side view, this is what I see. From the front view, this is what I see. Therefore, you project this curve to this, and you can see I'm getting the same curve. Those are 3 ways you can use. You can get a 3D curve. Either use the projected curve here, use intersection curve, or split. Yeah, okay. Therefore, this one I can delete. Don't need it. Okay. Okay. Now, next is, as you can see, this curve, this surface from this view. This is the curve I've drawn, but now I have to capture this section here, and this curve is tangent to this, not curve, this surface tangent to this section. Basically, this is the curve I've drawn, and I have not included this curve. I want now to create a construction elements at this edge. Okay, therefore, I need to go back to the front plane, do a new sketch here, and draw an arc. This arc, this point to be to pierce. Okay, let's then use coincident. Yeah, number 2. I'm not supposed to use this. Let me not use this. Let me delete this point here. I want to use another line for construction. Let me draw 2 lines here. One is 46.5. This one is 45.75. This point, this point here coincident. If I want this curve and this point to be coincident instead, then make it shorter. Then I want this and this curve to be tangent, then this point and this point to be like that. Same case applies on this side, this point, like that. Yeah, because I want to extrude the surface. This surface will be used as like it is my construction element, such that once I now design the surface that goes here, I will use this surface as my reference. As you can see in this mouse here, this section kind of go inside. You can see it bulges inside. Therefore, we need to capture this curve. See this line here, so that I will now later loft. I will later loft that curve to this and use these two as my guide. Once I use loft now, I loft this to this using these guides. Therefore, we need a curve at this point here. The best thing is to do is go to right this point here, and we need a plane at that specific point. Okay, let's now make a sketch on this plane. Then we need a line first. I want this line, this point, and this point to be coincident. Same applies to this to be coincident. Let me first of all hide these surfaces. Then I need a spline from this point to somewhere inside. Basically, the reason why I'm selecting a space inside is because you can see this one doesn't, if you go left, the bulges inside doesn't go directly to the to the top plane. The bulges inside. The reason why now my curve is supposed to bulge inside a little bit. Therefore, this one is of course vertical. This one to this tangent. This is my construction element. And let's see. I want dimension from this point to this point here. I want to use a 23. There. I think I have to reduce this to, let me create a construction line for ease of dimensioning. From this to this one, let's go with the 62. Oops, 62. Then length of this to be 4.5. This to be, let me go with 14. What else remaining? Let's see. Move them around and see what moves. I think this is fine because this one is a vertical also. Yes, and this are tangent. Why not fully defined? Let's see. Okay, can't understand why not fully define this. Okay, but now, let's now use it the way it is for now. That's fine. This one is a curve that will be used to define my side profile. Looks a bit sharp. Let me just edit a little bit. I want to go more inside by making this 4. And if you go 16 here, what happens? Let me go 13. Yeah, that's better. Now we need to define, if you go back to the mouse, you can see now this one is connected to a curve that is somewhere inside. Let me first of all hide this fillet so that can basically what I mean is this curve is lofted to another curve that is a little bit inside. Therefore, instead of using the normal, this one, instead of using the one we had sketched, sketch 1, I want to have another one that is a little bit offset, is offset from this. Okay, therefore I need a sketch on top plane, and let me hide this. This is the point I'm going to use, also this point I'm going to use to attach my spline like that. Then there are two splines, then another spline from this point to this point. Then another point, let me put a point at this point here. Dimension from here to here to be 10.75. Therefore, then this to be vertical, this to be vertical, this horizontal, this horizontal, this and this equal, make them equal. Then from this point to this point we need around 23. Then let me pull this. That's fine. Let me also pull this and see. Okay, these two, this, let me see if I dimension this to be 36, this to be 20, going to be 16. Yeah, I've already defined. Okay, here they look so close here. Let me see what happens when I make this to be 18. Yeah, that's better. Now you have that inner sketch. Now the next step is let me just hide this plane. Next step is now to loft. Let me see whether I can use boundary surface UV. I can use this one to this. Okay, V, I can use this and this. Yeah, boundary surface can work for me. But for the U ones, I can use a match tangent with this face, this face, like that. On the new, yeah, you're getting this from the boundary surface. Also, you can use loft. Okay, let's see how it looks like. Let's see the zebra stripes. Can see we have some discontinuity here. Therefore, for me to have continuous here, for these two zebra lines to be like continuous, let me go back to the UV second one here. How to use match tangent. As you can see here, I use the edge of split. Let me go normal to profile and see what happens. Yeah, doesn't allow this. Otherwise, I have to go to none. But this one is our construction surface. We don't need to consider it so much because we're going to basically we're going to change how this surface flows. We are not considering this, but here we have to consider this. Another one is another boundary surface. Let me see the sketches here. UV. This U wanted to be match tangent to the profile. Let's use loft and see what happens. Surface, loft this to this. The loft usually goes from, you can see how it has done this, goes on to let me do a new. For this one to be start to be tangent, match tangent to this face. Yeah, loft is okay here. This face, that's fine. Then add, we want to see start and add profile condition. match tangent of this face. Okay, then we need guidelines. This one to be my guide and this to be my guide. Okay, I want to add to this. Yeah, let me first for do new, then let me add this to manually. Let me do some visualization of our zebra stripes. You can see here how they flow. We don't have a smooth continuity from this face to this face, but you can see the boundary one is more smooth. You can see this side is smoother than this. Let's see if we can use the boundary instead of loft on this side. uh Come here, select boundary, this to this. Okay, oops, here I'm supposed to select here U profiles are this, then V profiles are this. Let's see the differences. For the U profile here, match tangent to this face, then also this here, let's match tangent to this face. Okay, continue. Okay, then let's do boolean and add these two. Let's now perform the curvature visualization color map and see what happens. Not color maps, let me use zebra stripes. Basically, we are getting almost the same thing, but you can see the border one is more smooth. You can see this smoother. We are smooth. We are smooth than the loft one. Let me go back to this boundary. For the top one, let me use match tangent to this face. Okay, let's see what happens. You can see when I select match tangent, now my stripes, they match. This side they don't match. Come here, edit, let me use this one here, match tangent of this face. Once I select match tangent, now my surface can flow easily. Can see, yeah. Okay, okay, now I can hide this. Yeah, that's how you model the side section, this section here of our mouse. In my second part, we will model now this section and this section here. I'm going to create this video in five sections or 4 depending on the length. Yeah, don't miss the next video. We're going to continue from here and eventually we will model a full mouse. Bye, thank you, see you in my next video.